Now we will talk about batch normalization. What is batch normalization? So batch normalization is a technique used in deep learning by normalizing the output of each layer to have zero mean and unit variance, reducing the internal covariate shift and improving the performances. What is batch normalization? It is used to kind of scale up the data on a value in order to reduce it to a value where we can have the data with central value as 0, which means if I scale the data, the central value will be considered as 0, which is going to be mean of the data, and unit value as a variance. So batch normalization, it is used to improve the training of the neural network, and as we know, neural network has multiple neurons, it has multiple hidden layers, input layers, so there is a computation challenge all the time. So it is always better to normalize the data and reduce the data complexity. It helps to address the problem of internal covariate shift. Okay, now internal covariate shift is all about getting covariance among the internal input parameters, which refers to the phenomenon where the distribution of the activation of a given layer changes during the training part. And while training the data, it is possible that the internal covariance is always shifting, which usually happens in a machine learning problem. By reducing the amount of covariate shift in the network, batch normalization can lead to faster convergence and better generalization of the performances. So, by using or reducing the covariance shift in the data, it will reduce the uh, problem of covariate shift. Batch normalization is often included as a standard component in modern neural network architecture. So, it is a standard component of modern neural network architecture. And in order to train deep learning network, it is as it is a complicated in nature, the that it has multiple input layers, and it requires training, and at each level of training it may encounter covariances among the data. So batch normalization helps us out. Batch normalization slows down the training by requiring lower learning rates and careful parameter initialization, which makes it notoriously hard to train models with with saturating non-linearities. So, so when we talk about um, when we talk about uh, when we talk about internal covariate shift, so we require training of data in a way that if there is an internal covariate shift among the data, so at every level what is happening is if there is a neural network and there is a neuron, and if there are certain parameters which are associated like weights and all, so if this weights keeps on changing due to that internal covariance shift, so the data training of each and every neuron will not be correct, and that is why such kind of problem may occur. Okay, so it will reduce the speed of the execution as well. So the deep learning backpropagation also will gradient descent operation, learning rates, everything will get tempered because of that internal covariance shift. So this problem can be addressed by applying batch normalization method. So batch normalization method normalize the input before feeding to a layer. It draws its strength from making normalization a part of the model architecture and performing the normalization for each training mini batch. It allows the use of much higher learning rates and be less careful about initialization of the weights. And it also acts as a regularizer in some cases, eliminating the need for dropout. So basically it helps us to eliminate the need for dropout because it regularizes certain parameters at certain level. So batch normalization kind of reduces the dependence of certain parameters as well. Here we have the batch normalization. We can see mini batch normalization where we take the average of the value by taking x of I divided by m, summation of x of I divided by m. Then we have mini batch variance values. So summation of xi minus mean of b the square divided m, which is similar to our mean squared error kind of function. Then we have normalization by using this z distribution normalization method, but here we are introducing plus epsilon, where xi minus mu b divided by square root of sigma square b plus uh, mu b is there, sigma is basically our standard deviation. Now then we have scale and shift method where we can use min max kind of operation, where gamma into xi plus beta, which is kind of scaling and shifting the values in order to get this batch normalization. So we have these all levels of batch normalization which can be utilized to normalize the data, and that's all.